Hey guys, this is the this is the quiz review for next week's quiz, or the next quiz whenever you're taking it. But congruent triangle quiz review. Here we go. This is the one that's for a grade. Make sure that you turn this in. Looking at this video and watching me do it is not a substitute for you trying to do it on your own. Make sure that you're always trying things on your own without help first, getting help, and then going back and doing it on your own without help later. To make sure that you really know it. One of the things that I want to kind of talk about here in this first section, equilateral triangles, also equiangular triangles. Equiangular, equilateral means three sides are equal. Means three sides, three angles. Isosceles means 2 plus. It could be 2 equal sides, it could be 3 equal sides. It means at least 2. Isosceles is at least 2, and scalene is 0. Keeping that in mind, let's go into some questions. Sometimes, always, or never. An equilateral triangle, so that's 3 equal sides, is a right triangle. Well, if all the sides are equal, that means all the angles are equal, which means all the angles are 60. That is never going to be a right triangle. An isosceles triangle, 2 plus, is equilateral, 3. Can 2 plus ever be 3? Sometimes. Right? If I told you, hey, I got at least 2 cats, does that mean I have exactly 2 cats? Nope. It means I could have 2, but I might have 3, I might have more. Isosceles means at least 2. 2 plus isosceles is scalene 0. Does 2 plus ever mean 0? No, never. Exactly 2, and 3. Is exactly 2 ever 3? No, never. Now, if I took this word out, if I just said 2 sides and 2 angles, if I deleted the word exactly, now it's sometimes. But the word exactly means it is 2, not 2 plus, it's 2. Scalene, that's 0, is a right triangle. Well, we got to think about this a little bit. So can a scalene triangle be a right triangle? Could it be a 90? Man, this is really thick. Could it be like a 90, a 30, and a 60? Yeah, that's scalene. Right? If 0 angles are equal, could one of them be 90? Sure. But do they have to be? Could it be like a 50, 60, 70? Is that scalene? So this is an example. This is a counterexample. It's got to be sometimes. Scalene does not have to be a right triangle. Equiangular, equal angles. That's 3 equal sides, 3 equal angles. Is that 2 plus? Yes. Is that 3? Yes. Is that all less than 90? Yes. If it's equiangular, once again, they're going to all be 60. So is that acute? Yes. It's all those things always. All right, tough question here. You got to really understand what you're reading. The first sentence determines your fate. The hypotenuse of an isosceles right triangle DEF is DE. This is the most important part, but it's all important. I need to draw an isosceles right triangle. One of the big mistakes people constantly do is they just glance over it and don't pay attention to the individual words. Isosceles triangle, I know at least 2 sides are going to be congruent. And it's a right triangle, means I have a 90-degree angle. Well, if it's a right triangle, this is the hypotenuse and these are the legs. What do we know about the hypotenuse? It's got to be the longest side. So it's got to be that the legs are equal. If it has to be isosceles, those 2 sides have to be equal. And let's read it. It says that the hypotenuse is DE. So the hypotenuse has to be my D and my E, which means F has to be the right angle. Okay, well, they tell us that DF is 2x squared minus 20. And EF is x squared minus 2x plus 15. Well, if we didn't read the question carefully, we would have no idea what to do. But because we know those are equal legs, we can now say that 2x squared minus 20 is equal to x squared minus 2x plus 15. I'm not going to spend a long time explaining this. We make one side 0 and we factor it. That's in other videos. We need to be getting pretty good at this. But I need to move everything to the left side. Subtract the x squared, add the 2x, subtract the 15. That's going to get me x squared. That's going to get me plus 2x. Sorry, I got cords in my way, fam. Okay. That's going to get me plus 2x and then minus 35 when I move everything over. Factor that. It's the factors of 35. This tells me they have to subtract to equal 2. Well, those are going to be 7 and 5. So the factors of 35 that subtract to equal 2 are 7 and 5. And I need it to be plus 2. How do I get plus 2? By plus 7 minus 5. So what does x equal? Negative 7 or positive 5. Okay. But it's geometry, so we got to test this out. We need to plug it back in. People mess up plugging in all the time. 2 times negative 7 squared minus 20. That is 2 times 49 minus 20. If you don't put the parentheses here, you're going to get it wrong. And that's going to be 78. Go over here. Negative 7 squared minus 2 times negative 7 plus 15. That's positive 49. If you type it in the calculator wrong, you're going to get it wrong. You must have the parentheses. Plus 14 plus 15. That's 29 plus 49. That's also 78. Is 78 an acceptable answer? Yes. So it could be 78. Plug in 5. 2 times 5 squared minus 20. That's 50 minus 20. That's going to be 30. Over here, 5 squared minus 2 times 5 plus 15. That's 25, 15 plus 15, also 30. So does 30 equal 30? Yes. Is 30 acceptable? Yes. They both work. You've got to chime in at answer choice D. It's got to be D. Don't tell me B. Don't tell me C. It's got to be this one. Both answers work. I need both answers there. Make it happen, fam. Okay. This is the stuff we did last time. This is like 20% of your quiz is just can you identify congruent shapes. Here we have angle, angle, and there's a whole video on it, so I'm not going to take a long time on these. But we have 2 angles and the included side. Is that side holding hands with both angles? Yes. So in the name, it needs to hold hands with both angles. S is holding hands with both angles. The S is holding hands with both angles. Got it. Here, we have parallel lines. We can't mess this up. Parallel lines, what do we know? We know that we start, we turn, we finish. We know that those angles are going to be equal. That's what we know. Can I do the same thing this way? No. The left and right, they didn't say those are parallel. No. And then we have a shared side in the middle. So look at the triangles. What do we have? We have side, side, angle. Is that angle holding hands with both sides? Is it in between? Yes. The angle's holding hands with both sides. It's right there, touching both of them. Now, a big mistake that people make on this, just to kind of talk about it, is they tell me it's angle, side, angle. But what's the problem there, guys? That you're crossing triangles. You can't go cross triangle. So don't say that, please. It's not that. It's going to be side, angle, side. Here we have a shared side. Once again, angle in between, side, side, angle in between, side, angle, side. All right. I'm going to start with the number 1 mistake. The number 1 mistake is parallel lines are congruent. Wrong. We've talked about this. I'll show you one more time. Are those the same size? No. Just because they're parallel doesn't mean they're the same size. Please don't do that. Parallel lines give you angles. Angles. So if the top and bottom are parallel, they give me angles. They give me corresponding angles. Alternate interior angles. If I I know that those are going to be the same size. So those use the top and bottom, but guess what? We also have left and right. The left and right are also parallel, guys. So I can go those work as well. That didn't happen on the other picture, but it does on this one. So we have parallel all over the place. And then we have that shared side. So it's, if we focus on one triangle, please focus on one triangle. We have angle, side, angle. Does the side touch hands or hold hands with both angles? Yes, it does. All right, that's angle, side, angle. Down here, I'm going to go quick. Parallel lines. Got them. So those are equal. Can I do this way? No. These are not parallel. No. Don't do that. We have a shared side. This one's a little bit wacky. We have side, side, angle in between. That's SAS. But on the other shape, we have side, side, non-included angle. Is this angle holding hands with that side? No. Just staring at them. Just staring at them. It's not holding hands with it. This angle holds hands with these two sides. So no. So this one is SSA. Well, that's not even a match. You're not allowed to say SSA ever. It's not a match. NEI. Not enough information on that one. All right, this one's a little bit tricky. This one's tricky. Parallel lines give you angles. Angles. Those lines are parallel. Do you see any angles that touch those lines? I see a few, but there's this one. And if I go, then it goes with that one. But that's not super helpful. That other angle is not in the triangle. There's some other things we could do with that, but I'm not going to mess with that. But we also have this one touching that red one, this one touching that red one. If I draw that transversal, do you see the letter F, the red letter F? That tells me that the inside corners are going to be equal to each other. Those are corresponding angles. They are equal. So that's based off the red lines. What about the green ones? Same situation. If I draw the transversal, don't these corners make the letter F? Aren't those going to be corresponding angles? The answer is yes. So here we have corresponding angles again. This one's ASA. Guys, on these questions, if you do not mark your picture, I will count them wrong. So if you leave off these markings, like if this wasn't here and you said ASA, it's wrong. You must have your picture marked to support your answer. All right, this question. It was on the last assignment. It's been on previous chapters. We've got to know how to do this. The only new thing is classifying the triangle by its side lengths. We didn't classify it before. We found perimeters before and things like that. So these are out. The quiz won't have multiple choices though, guys. So you can't just look at this. You need to know these are my only options. If it says classify by side lengths, it's got to be one of those three. No ifs, ands, or buts about it. How would I figure out the side lengths? Well, that's distance. We're going to do three distances. We're going to find the distance from X to Y. We're going to find the distance from X to Z and the distance from Y to Z. There are three sides, right? If I draw this triangle and call it X, Y, Z, there's three sides, X, Y, X, Z, Y, Z. I need all three distances to confirm if it's scalene, isosceles, or equilateral. So distance, let's go. It's the square root of XY. -3 to -1. That's 2 apart. We square it. We've done this a lot. There's other videos. Go back and watch them if you need to. 1 to 3. How far apart are those? 2. We square it. It's a squared plus b squared equals c squared. Well, that would be the square root of 8. And I'm just going to leave it like that. We're just comparing. It's easier to not simplify it if we're going to compare them. At least I think. All right. So then we move on. Let's do xz. 1 to 3. That's plus 4. 3 to -1, that's also 4. 16 plus 16, that's root 32. So equilateral's off the table. And then finally, YZ, that's -3 all the way to 3, that's 6. And then 1 all the way to -1, that's 2. That's 36 plus 4. That's 40. Those are all different. That's scalene. If you don't have all this work on the quiz, I'm counting it wrong. I need to see all the distances you're doing. I'm telling you, same question, different numbers. You need to be able to do this. So there's no doubt about this question. All right, congruency statements. It can be really helpful to draw the picture out. Even if they already have a picture, confirm it's drawn correctly. They won't always draw it correctly for you. I'm going to go left, top, right. There's FBI. And then I'm going to make the same looking triangle. Oops. The same looking triangle and call it USA. Left, top, right. Left, top, right. FB, 88. UA, 2x minus 16. BI, 3x plus 10. FI, 40. So looking at this, what are the things we know? If that's 88, then this is going to be 88, right? Look at the name. FB and US are the same. BI, well, that's going to be 3x plus 10. And then this one, what do we know about that? This is also 40. So there's our equation. We know that 2x minus 16 must equal 40. We know that from the name. So 2x must be 56. So x must be 28. But they didn't say what is x. They said what's the perimeter. So take the 28 and plug it in. 3 times 28 plus 10. 3 times 28, 60 plus 24, 84, 94. So that's going to be 94. So what do we have here? 170, 182, 222. I don't want to be wrong in the video, so I'm going to type it in just to make sure that I didn't mess up. But 3 times 28 plus 10, that's 94, plus 88 plus 40 is 222. All right, I just didn't want to be wrong. Got it. But there we go. 222. Same situation. All right. I'm going to be smarter about it this time. I'm going to copy and paste. So there's my two triangle. Oh, sorry. I didn't know. I didn't know. Stop it. Okay, sorry. I just found something new. Okay, sorry. I did not know you could do that. Okay. That changed. Okay, okay, sorry. FBI is congruent to USA. It says FB is 41, SA is 28, AU is 6x minus 7, and the perimeter is that. Well, if that's 41, this is 41. This will be 28, and this will be 6x minus 7. They're the same triangle. They told us they're congruent. So, how do you get the perimeter? To find the shape's perimeter, perimeter. To find the shape's perimeter, just add all the sides. So we know that if I add all those together, it has to equal the perimeter. So I add those together, I get 69, 62. So 6x plus 62 would equal 8x plus 46. So 2x would equal 16. So x equals 8. Okay. So if x is 8, we plug it in. 6 times 8 minus 7, 48 minus 7 is 41. So 41, 41, ooh, so it's isosceles, which we kind of knew if we read the whole question. But the triangle is isosceles, and state the vertex angle. So since there had to be a vertex angle, then it had to be isosceles. But the vertex angle would have to be the one between the 41. That would be angle U. Over here, it would have to be angle F. Which one did they want? State the vertex angle of FBI. So it's got to be F. So it's isosceles. Since F touches the 41s, remember the vertex angle touches the congruent sides. So we know that F is the vertex angle. All right, and then this proof. Let's do it. So angles 1, 2, and 3, 4, 5, and 6. So this is a Schoology assignment, so I had to get creative with it, and I'm really sorry. I probably should have just numbered the angles. Actually, I know I should have, and I'm going to do that in the future because it gets real messy. Like, look, it's called angle EAT, and I even messed up. That should be equals, not congruent. So, ooh, I'm embarrassed. Okay. And actually, honestly, I should have just taken the M's off. I don't know. And kept it congruent. We've talked about that a little bit. Doesn't matter. Not a big deal. Okay. But like EAT, angle EAT, that's angle 2 in my picture. So keep that in mind. So let's write the proof. Well, the first thing, it's all given. Now, we don't have free choice. We have to go by our options here. If it was a free response proof on the quiz, we could do a few different things here, but we're locked in. There's really only one option for us to prove. So we have those two blue lines. They told us they're parallel and congruent. Does parallel automatically mean congruent? No, but they are this time. So what are the things we know? We know that these angles are equal because they're vertical. We can go 1 to 6. Those are alternate interior angles. We could also go 3 to 5. Well, E and H are not down here. I know that because I made it. T and Y are, but E and H are not. So we're not going to be able to use those in this proof, but if you were doing a free response one, you could. But we're going to ignore those because they're not really a choice for us this time. So this is going to be our proof. Those are going to be the ones we have to use. So the first thing I'm going to say is angle T is congruent to angle Y. And I'm just doing that because that's what they said down here. I like using the numbers. But angle T and Y, that was because of alternate interior angles. That's how we have T and Y. The other thing we have are 2 and 4. But remember, they named the whole thing. So I'm going to name the whole thing. And look at this. That is triangle. And this is angle. Triangle and angle are different. The angle EAT is EAT. It's this corner. Triangle EAT is the whole shape. All right. So we're going to say angle EAT is congruent to angle, what they say, HAY. And how did we know that? That was because they were vertical angles. Since these are independent, right? Did I have to know this in order to know that? No, these do not depend on each other. These are independent pieces of information. Could I flip-flop my line 2 and my line 3? The answer is yes. But once I know both of them, do I have enough to say the triangles are congruent? Yes, I have angle, angle, non-included side. So I can say triangle EAT, and I have to get this right. If I go from E to A to T, that's blank 1 dash 2 dash. So I got to do blank 1 dash 2 dash. It's got to be HAY. That's something you have to be able to get right. And we said that's angle, angle, side. I'm going to go real quick here. Oh, no, actually not, because I want to talk about this. It's asking us to prove. Sorry, guys. It's asking us to prove A is the midpoint of TY. So I'm going to flip that on you. What if I said, hey, man, A is the midpoint of TY? What would you know? You would know that these are equal. Oh, I'm so sorry. From a long time ago, those are still marked congruent. Or wait, no, they are congruent. I am really confusing myself. Sorry. Sorry, we're trying to prove A is the midpoint. Sorry, if I said, hey, A is the midpoint, I just confused myself with that. We would know those are congruent parts. So what kind of evidence are we looking for? If these are congruent sides, would that make A the midpoint of TY? The answer is yes. So we need to say AT is congruent to AY. And let's see, where is that? AT is congruent to AY. That's CPCTC, right? AT, AY, we know they're congruent from the name we just wrote down. So AT is congruent to AY. Now, do we know that that's the midpoint? Yep, and that's just the definition of a midpoint. So once we knew those parts were congruent, right, AT and AY, that made A the midpoint. Now they're congruent. Now A, we know for sure, is in the middle. All right, guys, that's every question. That's some good stuff. Love y'all.